Welcome to Tech Talk with Steve. My name is Steve Cowles, your host, and I am the Technical Services Manager with AEM. Today's topic, wired and wireless networking. When Kaput happens, I appreciate Lisa and Jacqueline working a German word into the title here. Having spent 9 years in Germany as a child, I'm very familiar with Kaput. And for anyone who isn't, that word means broken. So today is a special show. We have a very special guest, Andrew Froehlich. As a highly regarded network architect and trusted IT consultant with worldwide contacts, Andrew has over 2 decades of experience and possesses multiple industry certifications in the field of enterprise networking. Andrew is the founder and president of Colorado-based Westgate Networks, which specializes in enterprise network architectures and data center build-outs. He's also the founder of an enterprise IT research and analysis firm, InfraMomentum. As the author of 2 Cisco certification study guides published by Cybex, he's a regular contributor to multiple enterprise IT-related websites and trade journals with insights into rapidly changing developments in the IT industry. Please help me welcome Andrew Froehlich.
Hey, Steve, how are you?
All right, Andrew, how are you doing today?
Doing well, and thanks for having me on. I'm really, when you asked me to come on and told me it was about the NSA product, I was really excited about it because it's such a unique product for the market.
Oh yeah, quite a few features packed into one unit.
Absolutely. I think to start, to kind of introduce people to what the NSA is, I'd like to start with what Certalite is. And to give you a little bit of background, one of my larger clients that I consult with, they had an upcoming IoT project where a large number of the deployed IoT devices were going to use existing twisted pair cabling. And while this Cat5 and Cat6 cabling was certified years ago when it was installed, the client requested that each cable be retested for this project. So while I simply could have hired, a professional contractor to rerun these certification tests, I also could have purchased like a full-blown certification kit like the AEM Test Pro. Both the client and I concluded that a full recertification, it didn't really offer the most bang for the buck because there was really no need to do a full recertification as the cabling was already under warranty. Right. So instead we leveraged my NSA tool to run Certalite tests. So Steve, can you speak to the differences between full certification and Certalite and perhaps show how to run a Certalite test?
Sure. So certification is going to be a dual-ended test. They're laid out by the standards. So, the TIA standards will specify what parameters, need to be run. And it's done in a bidirectional method. So you'll have, in our case, where we have 2 identical handsets on each end, and those units will run tests bidirectionally. Mm-hmm. So you're testing from each end. Other systems will have not really a dumb remote because there is some intelligence in those remotes, but they don't have a display on them. So there's limited functionality on the remote, but it has all the testing hardware in it. So all of that is running back and forth. The main and the remote are synchronized, and everything is done and is driven by the main, and it controls the remote. Whereas with qualification, typical qualification is a single-ended test. From basic qualification, it might even be just something as simple as a wire map and a TDR indication of how far out an open or a short is. And that's, at the very basic root of it, just a wire map tester. And then others will add things like some basic Ethernet testing or discovery. You might, yes, there's a switch on the other end just to validate. Whereas what we've done with the NSA and the similar features, in to what you would have in a certifier, we've taken that dual-ended test and boiled it down to a single directional test. So we're testing from the main into a remote terminator, and we do all of the parameters that you normally do in a certification test. So all those RF parameters, DC resistance, the crosstalk, return loss, insertion loss, all those normal measurements you would expect to see, those RF measurements, including TDR traces to find where the problems are with things like return loss and crosstalk. So that's all kind of boiled down into a single-ended test. Still using the TIA 1152A standard. So we are using the normal test limits for certification, but because it's not bidirectional, it's not considered certification. So we coined the term Qualification Plus, which is what our NSA is. And I can actually share my screen here, and I'll pull up the NSA here for you. I've got my NSA unit here. You won't see anything on the display because I'm VNC'd into it. So as you can see on the left here, I've got the display right there. So we'll be controlling it from the computer so everybody in the audience can see this. And what I'll do is demonstrate a Certolite test, which is our Qualification Plus test. So over here on the panel, I've got one of our remote terminators. So this is just a RJ45 plug with some circuitry in it, and it's our remote terminator. And I'm going to plug that into one of these jacks. Now this panel, I've got links looped from one port to the other. So I'm just going to first put my Certolite test on so you can see the display, and then I'm going to plug in, and we get an instant wire map. So the wire map's important because you could have a situation where maybe there's a problem with the wire map. So we bring it up right away. So if I plug this into a different port over here, I'll just go ahead and plug in. And in this case, we see a problem with this wire map. We have an open and a short. If I click in the middle of the wire map, what's going to happen is the NSA is going to run a diagnostic of the wire map and tell me how far out that open and that short are. So I see about 46 feet for the short, about 48 feet for the open. My experience tells me that's at the same event on the cable. So I'll go back to the good one here, and we'll plug in, and we'll just run an auto test to show you what a Certolite test looks like. Now this will take a little longer. Our certifier runs a 6-second Cat6A auto test, including DC resistive unbalance. The Certolite takes a little bit longer because you're only controlling it from one end. So there's a lot more that the main has to do.
Sure.
So here we can see are the normal things you would see in a certification test. Your DC resistance values, all your margins are shown here, your length. We've got the wire map. And then if I look here, some details, I can instantly tell this cable is good enough for 10 gigs. So the instance that you talked about, they want to know if their cable is going to support future applications. Right. This is perfect. And then you can scroll down and through all the other values here. If you want to see the resistance, we also include resistance unbalance pair to pair. And in this case, I see I've got a couple here that are suspect. This cable, I would be a little concerned about maybe running some PoE because there is some resistance unbalance in it, but it's not enough to cause it to fail. Because resistance unbalance isn't part of the normal pass-fail criteria. And then if you did have an issue with the cable, you can actually scroll down and see things like our RL locator and our next locators. So here we can see a bit of return loss at the near end. Same thing with crosstalk. You can see where the crosstalk is along the cable. So you get all this information in one test.
That's awesome. I kind of see this as a perfect network administrator tool, like for in-house IT and network admins, because most of the time they don't need full certification, but this gets you as close as possible at a much lower price point, right?
Exactly. And that's the driving factor behind us bringing the network service assistant to the market, is that it fills that niche. There's a lot of people who they don't want to spend the money for a full-blown certifier. Now, granted, our certifier is going to come in at a lower price point than a lot, but the application is they don't want to have multiple pieces of equipment, and some of these folks don't really need certification. And a single-ended test like this is plenty for their needs. And on the odd occasion that they might have to do a deeper dive on the cable, they can always shoot from the opposite end. They can swap that remote terminator, put it on the other end, and shoot in a different direction. So they can actually examine the cable in two directions if they ever needed to.
Yeah, great point. Cool. So let's move on to another topic that's kind of near and dear to my heart, which is network test and troubleshooting. So since I'm a network architect and administrator and engineer for the last 20 years, I've run plenty of network tests and troubleshoot plenty of networks. And with the NSA, I would venture to guess that over half of my time spent with the NSA tool was for network test and troubleshooting purposes, both from a wired and wireless perspective. So Steve, I'd like to kind of walk through some of my examples, and maybe you can show everybody how the NSA tests for each of these.
Sure, absolutely.
Awesome.
What I'll do is I'm going to switch into network testing mode. So all I'm going to do is I'm going to change ports here. Notice I'm not having to change any adapters or reconfigure anything. I'm just going to click on multi-gig because that's going to activate my multi-gig port, which will do multi-gig testing and PoE and all that. But it also is where I want to drive my my network test through as well. So I won't need my remote terminator because we're actually going to be hooking up to some other things to show examples of what you're talking about. So I'm
Great.
set up and ready to go, and I'll let
All
you
right, so
ask questions.
let's go through scenario number one. Let's say a user is complaining that they have network connectivity, but maybe can't reach a certain URL, or maybe load times to that URL are really high, like things are slow. So this is kind of a case where basic tools like ping and traceroute would be used. Does the NSA have that?
Yes, absolutely. So what I'm going to do, I'm going to connect a jumper here I've got running over to my switch over here on the right. And this is connected to my home network. So I'm going to, I can see here, notice that the letters for this multi-gig indicator went green. That means I have a live connection.
Okay.
So I'm going to click my network test in cloud, and this will pull up a screen. It shows me I have a 1 gig full duplex connection. I'm going to go ahead and click onto network tests, and this screen will refresh in just a second. On the live tester, when you're using it in the field, this screen refreshes much more quickly. The delay we're seeing here is attributed to the VNC that I'm using here. So we're starting to discover devices. So there's a lot of things we can do in here, but I'll address the ping and traceroute that you mentioned. So I'm going to go into Tools. And then we've got a ping here. So we could ping Google, for instance. If we thought we had an issue getting to Google, we'll go ahead and start that ping. And you can enter whatever URL you want in there. Sure. I don't know if you noticed, there's a little add button, and you can add whatever URL or IP address if you just want to ping an IP address. And we can see that we're reaching Google. Delays look fine. We can go back, and let's assume that we did have an issue getting to Google. So we would go into traceroute, and then we'll just run a traceroute to Google. And then this will tell us, where's that delay happening? Is it local on one of our network routers that we're responsible for, or is it beyond? Is it several hops away, somewhere between here and the destination?
Yep. And sometimes the simplest tools are the best to troubleshoot with too.
Exactly.
So have those kind of in a small package where you don't have to constantly be carrying your laptop around in the field. That's kind of a nice to have.
Exactly. And most people can do a ping or a traceroute test on a laptop. So it's not that these, like you said, it's not that they're unique tools, but they're unique in a tester that also has the capability to do the type of physical cable testing that we're doing. So we want to give the user as much function in here as they can possibly get.
Absolutely. Cool. So let's do a different scenario. Let's say, what about when a user plugs into a new switch port, but they can't access certain parts of the network, such as a local printer, or maybe something that uses multicast. Now, in these situations, these are usually pretty simple problems where the user isn't connected to the correct IP subnet or VLAN, but they can also be somewhat troublesome to figure out what the problem is. So Steve, what can the NSA do from a troubleshooting perspective, knowing what VLAN you're connecting to?
So a couple things we can do here. We'll go first. I'm just going to click this icon of the NSA on the screen here, and what this is going to do, it's going to bring up information about the connection that we've made. So here we can see, we've got the IP address that we've obtained, our subnet. So we'll know right away if we're on the wrong subnet. We're going to see that here. We see the gateway. We see the DNS and DHCP information, and we can see that we do have a full duplex gig connection. Now, to go beyond that and look at where we're actually connected, I'm going to click this little icon in the lower right. This is for switch detail. And in here, you can run a test and get pull switch detail on either CDP, LLDP, or both. I'm going to leave mine set to both. And This will pull the switch. It's going to bring back all the information about the switch. And obviously, we're talking about managed switches here. If you just have a
Sure.
local workgroup switch, it won't give you anything. But for this, it's showing us the system name, so we know we're connected to Whopper Cheyenne Mountain. It's a Cisco SG258 port, and we see that we are in port 7 right here, and we're on VLAN 1. So the VLAN indication is something that will really help you if you know that VLAN 1 doesn't have any connectivity to the internet. It's an internal VLAN that doesn't allow anybody on that VLAN to get outside the facility. Then you know right away, okay, I am on the wrong VLAN, and I didn't mean to be in port 7 on this switch because I know that's an internal VLAN. It doesn't get me internet connection. So now you know that either you have to reprovision that port, set that VLAN setting on the port to be different, or you need to just physically plug into a different port that has the VLAN you're looking for. And
Absolutely.
the other stuff you can get, there's a lot of other information. You can see the IP address information for the switch and all the other details there too.
Yeah, this information that you can pull from the NSA, it can't be overstated. I mean, so many times I'm out in the field and, somebody might pull me aside and say they're having a problem with a specific, network jack. And if I have my laptop with me, I can plug in and get some information, but I have no idea what switch I'm connected to, what switch port. So this information that you can pull from the switch directly from the NSA tool, it's really nice to have.
Yeah, absolutely.
Cool. All right. So what about this situation? Let's say a user can successfully reach a server. They can ping it, right? But let's say they're having problems accessing web applications hosted on that server. So there's not really an IP networking problem because we can ping it, but perhaps the problem's further up the stack, such as TCP.
Yes.
Where can we go from that troubleshooting standpoint?
So we'll click the tools button again here where we found the ping and trace route functionality. And in here, we've got a TCP Connect tool. So if I click on the TCP Connect tool, I've got Google in here, for instance, port 443. And we can just go ahead and click TCP Connect. It's going to establish the connection. And once the connection is established, we'll click Test Response. And this will give us details about how that connection at that port is performing. So you can see, it is a TCP open port. We've got the IPv4 address. We can see our ping scan time, resolution time, latency. So this will allow you to dig a little deeper than just a simple ping test.
Very cool. Very cool. Okay, so let's talk about network visibility. So, everybody that's in IT networking and network operations, they're constantly talking about network visibility, right? So when we're at our desk, right, we've got access to all sorts of different network visibility tools, whether it's SNMP, NetFlow, artificial intelligence for operations, these new types of tools. But when we're out in the field, we're very limited in what we can see. So one of the coolest features that I think is fantastic in the NSA and in the Test Pro is something called device discovery. And
Yes.
Steve, you briefly showed us that, but can you kind of dig into that a little bit more and kind of show us what we could potentially see when we're out in the field?
Absolutely. So here we've got discovered devices. I can click on discovered devices, and so far we've discovered 9. We can see these devices by IP and MAC address. If host names are published, I can click on host name and get some resolution there, and it'll identify devices by whatever you've named them. We can click on any of these addresses, and we can pull up any details that are known about the device. So if the operating system is advertised, we'll see that on there. This one, I think it's odd. It's not showing us a distance. So we'll try another IP address here. Normally, you'll see a network distance, which will tell you the number of hops from where we're connected to the network. And typically, my home network, it's going to be 1 hop. It's not, I don't have a complex network here. And once the device details are shown up, and this one, we're not showing a hop distance either. Usually we'll see 1 hop here. So, but normally anything you get in here, you'll see a MAC address will show up. You'll see the number of hops will show up. Mm-hmm. And it tells you a little bit of detail about that device and what's going on.
Cool. Yeah, it's another really useful feature that, before before this existed, we probably weren't really thinking about it, but now that we do have it, it's really nice to have a tool for sure.
Oh yeah. Oh yeah.
So finally, go ahead, Steve.
It's also sometimes good to be able to look and see, you might have a limited list of MAC addresses that are on your network, and you can pull this up, and you're supposed to have 8, but you see 9.
Right.
Then you may need to look at, did somebody,
is it a rogue device or
yeah, exactly.
Absolutely. Cool. So we've been talking a lot about wired troubleshooting. Let's talk about wireless for a second, because the NSA can do wireless troubleshooting.
Absolutely.
And when we're talking about Wi-Fi, it's a lot like chasing ghosts, right? A problem's here 1 minute and it's gone the next. And really, without the right troubleshooting tools for wireless, they can go unresolved for years potentially. And many times the problem does end up coming down to dead spots or external interference. Again, pretty simple problems, but hard to find, hard to identify if you don't have the right tools.
Right.
So Steve, can you share some of the Wi-Fi signal strength tests that can help us identify these types of problems?
Absolutely. So the first screen we see here, we see a list of SSIDs and their associated RSSI signal strength value and the channel they're on. The one we've connected to here, Sheldon-Oplis 2.5, if I click on the connection option, we've got some toggle on and off functionality here. You can set it to not auto connect or auto connect, enable Wi-Fi handoff. What the handoff does for us, it allows us to roam the facility. And when that signal strength gets below whatever number you specify here, like, we have neg 60 here, but we might do neg 67. That's what they drove into my head when I spent a week at the Bixby Wi-Fi course a long time ago. And so you put whatever value you desire for your network there, anything between neg 60 and neg 90. So what'll happen in this case, it's negative 60. As soon as it drops to negative 61 and stays there for more than a couple of seconds, it's going to disconnect from that network and find a stronger known access point or SSID. So what we would do is, once we've set that handoff, we'll go into the signal strength tool, and you'll notice there's a network test button here. So for Wi-Fi, we can also do things like ping and trace route if we need to do those as well. So that is available. So here I would take this signal strength tool, I'd grab my NSA, I'd walk around the house here. And in my case, I've got a mesh network, so the handoff will be pretty seamless. And it's, in a bigger network, you'd have a lot more access points to reckon with. And what will happen is you get to a spot where that signal strength starts to dip, and it drops below that threshold that you set. You'll see it disconnect, and then it will find a stronger SSID and reconnect. Excellent. And that helps you find those dead zones. So you might find a spot where you're standing there and it just keeps disconnecting and trying to reconnect and disconnecting, trying to reconnect. That means you've found a spot where you don't have enough signal from any of your access points.
Absolutely. Yep. Or it could be the fact that you're bouncing between two access points, both with fairly low signal strength, right?
Yes. And it can't make up its mind which one it likes better.
So it's just bouncing back and forth, and you're constantly connecting, disconnecting. So.
Which to your point, that's exactly what's going to happen with somebody's laptop who's sitting in that spot.
Absolutely. Great. Let's transition again and talk about power over Ethernet, because I know that's a huge topic in the cable industry right now. So as we know, within enterprise networks, PoE is becoming increasingly relied upon. It used to be that only things like wireless access points and IP phones used PoE in enterprise situations. But now we're really talking about all types of IP connected things, such as surveillance cameras, door controllers, and various IoT and industrial IoT sensors. And just the sheer number of PoE devices being added to the network, combine that with the fact that these devices are requiring more and more power to be delivered over the cabling. I mean, I've seen it. It can spell disaster if the cabling is not properly installed and tested. So, Steve, what can the NSA do from a PoE test perspective?
So there's a couple things we can do from a PoE test perspective. The first one, when you're testing just the physical cable test, you'll look at those DC resistance values, and those will impact your PoE. That can give you an indication of why your PoE might be having trouble. But in order to find out what the trouble is, you're going to go in here and you'll use this PoE tool, and we'll connect, and we can select what PoE level we want. So, we can choose the BT 90 watt, we can go AT, AF, UPoE, whatever we want here. I'm going to leave it at 90. We see the allocated power here, 71 watts. This is the theoretical number that you will get. This is how much power you get on a good functional 100-meter length of cable. And that's what in the ideal world you would see. But if we do this, we go and put a load test on here. I'm just going to click that lightning bolt to put a load on. We can see the absolute power, or the real power, that I'm getting at this endpoint. It's 68.29. It's not 71 watts. Now, this difference on this particular link might not mean a whole lot for our PoE device, but you might see something here like 30 or 25, or even on the initial screen, you might find when you connect here, your allocated power might show up as something less, and that would be an indication that the switch is not provisioned properly. Because what happens here, the allocated power is essentially what the switch is telling you that it can give you, and the real world, unless you put a load on it, you don't know what it can give you. And then beyond this, there is another tool in here where you can do this over an extended period of time. So if we went external and had an external load on here, you could monitor this over time for intermittent PoE issues. And all of a sudden you figure out, okay, at 2:31 every morning, we get a PoE dropout and an Ethernet SNR problem. And we figure out what else happens at 2:31 in the morning. Well, it turns out there's a big compressor right next to the server room or something that's cranking up. So a lot of things can happen with that. Beyond that, we can go and run a multi-gig SNR test with PoE, and this will tell us what is going on with not just the PoE itself. And I'm going to set my limits. I'm just going to uncheck. Whoops. We need to change the profile here real quick to validator. And then we're just going to, instead of running all the way up to 10 gig, I'm just going to drop the 10 gig and the 5 gig out to save us a little time in the test, because I know we're getting close to time. And then we're just going to go ahead and I'm going to hit my test button, and we're going to run a quick test here. So what we're doing is we're running an IEEE 802.3 test, connection speed test at 100 meg, 1 gig, and 2.5 gig. And in addition to that, we're pulling PoE if it's available. So we're pulling that load, and we're also checking the SNR values for that 2.5 and above. So if we had done 2.5, 5, and 10 gig, it would do that as well. So what the SNR tells us is we know the value of the traffic we're putting on the wire right here, because that's what we're doing. We're doing an actual test where we put traffic load on. We've got PoE load. We're putting a normal demand on this link, and we're measuring the noise that could possibly cause issues on this, and we present that in an SNR value, signal to noise ratio. And the closer that SNR value gets to 0, the worse it's going to be. And typically a rule of thumb is going to be 3 dB. You want to have at least 3 dB of SNR on there. And then you see that, you see the 100 meg and the 1 gig here, and then we can see our PoE here as well. And this can be saved just like the Certolite report. So the network manager can have all the physical cable tests, and they can have these multi-gig SNR tests and PoE tests.
Right. Yeah, it's interesting. The combination of higher output PoE combined with the fact that multi-gigabit is moving away. It's moving out of the data center and into like the access layer of the network to support things like the higher end wireless access points and Wi-Fi 6, Wi-Fi 6E, as well as like ultra high definition surveillance cameras that are being deployed nowadays.
Right.
Those can destroy cables. And the fact that we have this SNR test to be able to verify that, yes, the cabling can handle multi-gigabit and PoE at load, that's a nice tool to have for sure.
Absolutely. So I just got a message from Jacqueline that we are at our 30-minute.
We are.
So we didn't get a chance to answer any questions. If there are questions in there, I'm sure Jacqueline will shoot them over to me, and then we'll respond individually. But I'd like to thank you very much, Andrew, for
it was fun
for joining us today. And it was great having you on, and great questions, and really appreciate the feedback. And appreciate that you're actually using this product out there in the field.
Absolutely. It's a great tool, and I'm happy to talk about it with you.
Great. All right, everybody, be sure to tune in every week, Tuesday at noon, for Tech Talk with Steve. Thank you for your time.